Good morning all. So let us see few more problems in today's class. So the first question is, so it is well known from elementary algebra that 1 plus x square plus etc. x raised to n, that will be equal to 1 minus x raised to n plus 1 by 1 minus x, provided x is not equal to 1. Now using this we need to show that the expansions 1 by 1 minus x is equal to 1 plus x square plus x cube plus etc. and 1 by 1 plus x is equal to 1 minus x plus x square minus x cube plus etc. are valid for mod x less than 1. And using this two series, you need to show that the series for log 1 plus x is equal to x minus x square by 2 plus x cube by 3 etc. and tan inverse of x is equal to x minus x cube by 3 plus x raised to 5 by 5 minus x raised to 7 by 7 plus etc. So let us look at how do we get these two expansions, 1 by 1 minus x and 1 by 1 plus x. So we are given that 1 plus x square plus etc. x raised to, we have x raised to n, that will be equal to 1 minus x raised to n plus 1 by 1 minus x. Now the series summation n equal to 0 to infinity x raised to n, so that is 1 plus x square plus etc. has Sn equal to 1 plus x square plus etc. x raised to n minus 1 ആയിരിക്കും വരിക. So therefore summation n equal to 0 to infinity x raised to n will be equal to limit n tends to infinity Sn. So that will be limit n tends to infinity 1 plus x square plus etc. x raised to n minus 1. So that will be limit n tends to infinity 1 minus x raised to n by 1 minus x varum. So that is limit n tends to infinity 1 by 1 minus x minus x power n by 1 minus x. So for the first term, that is independent of n, the first term in the limit, second term you have x raised to n. So that will be equal to 1 by 1 minus x minus 1 by 1 minus x into limit n tends to infinity x raised to n. Now when you have mod x less than 1, limit n tends to infinity limit n tends to infinity x raised to n. So when x lies between minus 1 and 1, limit of this term will be equal to 0, and when mod x is greater than 1, so limit n tends to infinity x raised to n, that is infinite. So we will have infinity when x is greater than 1 and it oscillates between So it is infinity when x is greater than 1 and oscillates between plus infinity and minus infinity when x is less than minus 1. So that is the case when mod x is greater than 1. So in any case a limit does not exist. So when mod x is less than 1, so we have limit n tends to infinity, Sn equal to 1 by 1 minus x. So therefore 1 plus x square plus etc. that will be equal to 1 by 1 minus x when mod x is less than 1. And again when x is equal to 1, you can see that the sum is infinite. Okay, so karanam series diverges because when you add up the ones, that is going to be infinity. And again when x is equal to minus 1, your sum can be either 1 or minus 1. So it will oscillate between, sum will oscillate between 1 and minus 1. So in this case, so when x equal to 1 and minus 1, series diverges again. So therefore we'll have 1 plus x square plus etc. equal to 1 by 1 minus x. And when you replace x by minus x, so we will get 1 by 1 plus x equal to summation n equal to 0 to infinity minus x whole raised to n. So that is summation n equal to 0 to infinity minus 1 whole raised to n x power n. Similarly, this also will converge when mod x is less than 1. Now we have got 1 by 1 minus x, so that is 1 plus x square plus etc. and 1 by 1 plus x is 1 minus x plus x square minus x cube plus etc. Now let us look at the series for log of 1 plus x. So let us call it a series 1 and 2. So when you integrating 2, so integrate 2, so upon integrating 2 you will get log of 1 plus x, that will be equal to, so you have c plus, so integrating here you will get x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. And when x is equal to 0, so that implies c will be equal to log 1, so that means c is equal to 0. So therefore log of 1 plus x will be equal to x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. So it will converge when, so your original series will converge when mod x is less than 1. So this is also valid for mod x less than 1. And again you have 1 by 1 plus x equal to 1 minus x plus x square minus x cube plus etc. So 1 by 1 plus x square is 1 minus x square plus x raised to 4 minus x raised to 6 plus etc. So upon integrating, again this is valid when mod x is less than 1. So integrating you will get tan inverse of x equal to c plus x minus x cubed by 3 plus x raised to 5 by 5 minus x raised to 7 by 7 plus etc. Again tan inverse of 0 will be equal to c. So that implies c will be 0. So therefore, tan inverse of x will be equal to x minus x cubed by 3 plus x raised to 5 by 7 minus 5 x raised to 7 by 7 plus etc. So that is again valid when mod x is less than 1. So that is the required results. Now the next problem is show that the series y equal to 1 minus x square by 2 square plus x raised to 4 by 2 square into 4 square minus x raised to 6 by 2 square into 4 square into 6 square plus etc. converges for all x. So let us look at limit n tends to infinity modulus of a n plus 1 by a n. So that will be limit n tends to infinity. So x raised to n plus 1 will be, so here corresponding to n you have the power as x raised to 2n. So you'll have minus 1 raised to n plus 1 x raised to 2 into n plus 1 by, you will have 2 square into 4 square into 6 square into 2 n plus 1 4 square by minus 1 all raised to n x raised to 2n by 2 square into 4 square into 2n square. So that will be equal to limit n tends to infinity. So you will get x square by 2 square into n plus 1 whole square. Now as limit n tends to infinity, 1 by n plus 1 whole square, limit will be equal to 0, so that is less than 1. So therefore by ratio test the series converges for all x. And I want you to do one more problem also. So let us show that the series for cos x, so that is y equal to 1 minus x square by 1 into 2 plus x raised to 4 by 1 into 2 into 3 into 4 minus x raised to 6 by 1, 2, 3, 4, 6 factorial plus etc. as the property. That y double dash equal to minus y you are given y, so find y double dash and show that it has this property. So kindly solve this problem.